In several of my past videos, I made a point to ask what speakers or headphones you reach for when I present my sound demos, and as it turns out, you guys have some pretty nice cans.
Oh, thank you, Doctor.
So today I'd like to interest you in a video about headphones that is totally not boring, for one, because it features a $1,000 set of planars, some interesting audio knowledge, also my take on the world's most awesome headphone holder. $4,000 is what I bleeped out just before the intro, and while that might seem like the bombshell to end on, my idea for this video is to share a few things worth knowing when, out of nowhere, something of this caliber shows up on your desk. No questions asked. That's my scenario anyhow, so feel free to discuss the price amongst yourselves while I run through a brief introduction. Right away, these are the Meze Elites, and you could, without much hyperbole, count these among the hypercars of the headphone world. In either case, the motivation behind the engineering is the same. How impressive a thing can we build if price is no object? Well, as it turns out, pretty impressive. Right away, these things won't struggle to hit the low note until around 3 Hz, which means that by the time we reach the threshold of the human hearing around 20 Hz, the output is about as effortless as you'd expect from any driver playing a whopping 2.73 octaves above its own lowest operating frequency, and the same applies up top. While our hearing tapers off around 20 kHz, the Meze Elites carry on for another 2.8 octaves, reaching an upper response limit of 112 kHz. Think of it as headroom in the frequency domain, with a buffer of 2+ octaves, keeping all the artifacts associated with isodynamic arrays reaching their limit completely outside of the sonic region, which also makes this middle part virtually free from harmonic distortion. So that's the technical pitch out of the way, now let's figure out a place to hang these. The footage you're seeing here is of my initial attempt at a headphone holder in the early months of 2021. It's basically just a 3D printed visor for the headphones to hang from with a little hook at the bottom for the cable. Convenient, but also not really, as I've since started a bin for that. And if nothing else, setting these up taught me some things to consider for next time. Things like the optimal spacing between the individual headphones, a more circular visor that maybe sticks out a little further, and perhaps a more secure wall mounting solution. Needless to say, the more time that I've spent on this in CAD, the more it began to resemble a traffic light housing, so I thought,
oh god, fantastic!
I think traffic lights are cool, and as a headphone holder?
Forget about it!
So I took inspiration from some of the more traditional railway and traffic signal images to design this. The square body of the front housing will measure 210mm per side, that's how far apart I want my headphones. The visor will extend 150mm along the protrusion. It will also measure 150mm across the outer diameter with a deep concave fillet along the bottom, providing additional clearance for large ear pads. A translucent lens will mount into the housing, completing the forward assembly. Then I'll stick some RGB LEDs into the rear housing to make this a functional traffic light. Best of all, the individual panels will mount into a grid with as many segments as I'd care to print. 4 in this case, and we'll get started on that in just a little bit. Anytime I bring home a new set of headphones, my first order of business is to fire up the DSP and reshape the factory sound into something kind of like an equal loudness profile for my ears. In a way, this is like applying a color grade over some raw test footage to see how good an image the camera can produce when everything is presented at its most faithful. However, I hear you ask, if we're just going to rely on digital processing from one set of headphones to the next, each time aiming for the same tonal neutrality, wouldn't they all just end up sounding the same? And if they did, why get the expensive ones? Right away, they would not end up sounding the same. In fact, it's not until the response becomes the common denominator that we can objectively evaluate quality. Consider, for instance, these two photos, one taken with an absurdly high-quality camera, the other with a cheap cell phone. And just like with sound, there is still a frequency scale, in this case of red to violet, and there is still an amplitude scale of dark to light. So, think of these as visual representations of sound coming from two different sets of headphones, each with its own baked-in factory default frequency response inadvertently coloring the overall presentation. Maybe this one exaggerates the bottom end so the reds are too bright, and maybe this one is lacking in the upper end so the violets are too dark. In any event, it is important to understand that what these variations in response illustrate is how the energy is distributed across the spectrum rather than any property of quality. So, if we wish to isolate or solve for quality as the only difference between these, we can't very well have two different energy profiles as our common denominator, and it's not until we eliminate these variations by way of a common response profile that we are left with nothing but the differences in quality without getting caught up in which one has too much bass or not enough treble. Our super awesome traffic light headphone holder project begins with some 3D printing. A lot of 3D printing, in fact, given the high infill density that I've gone with to keep the visors rigid. This is also the first time that I've gotten to use a clear filament, some pretty brittle stuff once extruded into a shape, though thankfully everything printed as intended and the supports released without much ado. As you can see here, the lenses themselves came out great, and I rather like the Fresnel effect caused by the layer lines, very evocative of the real thing. The grid was laser cut in several parts, small enough to fit onto the 24 by 24 inch sheets I had on hand. It's essentially a 2-layer staggered jigsaw puzzle held in place with glue and painted to match the black PLA. The assembly began with the lenses being fitted into the visors and held in place with a series of M3 screws. Perhaps somewhat of an overkill with the washers and all, but it does look the part. Next, here's a 4-pack of some generic remote-controlled LED pucks. Really, the only parts that I care about are the circuit boards, and with a steady supply of 4.5 volts, we're in business. These will mount into the rear housing plates, and with everything wired up, I can sandwich the grid between the 3D printed components. After this, it's onto the wall. Whenever possible, I like to run my headphones fully balanced, from the source all the way through to the drivers, and this can refer to several different technologies along the path. Right away, the connection between the DAC, the DSP, and the amplifier is balanced when two inverted copies of the same signal are transmitted from one device to the next, then stripped of any noise picked up along the way by means of differential rejection. This way, if I should encounter some peculiarity in the noise of the recording, I can rest assured that what I'm hearing is part of the track rather than something bleeding in through the electronics, and this is paramount for critical listening. Next, let's talk about how the amplifier connects to the headphones, and here Meze was kind enough to send me this really nice 2.5 meter long balanced cable, a perfect counterpart to the 1.2 meter long single-ended version included with the Elites. If you're wondering about the difference, it's about 1.3 meters. Alright, let's talk single-ended versus balanced. No doubt you're familiar with this plug, be it of the 1/4 or the 1/8 inch variety. It is a single-ended TRS connector, and we call it that because of the shared negative lead, which makes it so the voltage for either channel can only swing in the positive direction. This is in contrast to a balanced interface with two independent ground leads, each connecting to its own isolated amplifier, effectively doubling the electrical slew rate with a full positive to negative voltage swing. You could also equate this to the difference between a piston compelled to move only forward of its resting position versus one that can move in both directions. Best of all, virtually any set of headphones with detachable cables can be wired balanced. Of course, you still need a proper dual mono balanced amplifier to drive them. Anyhow, the reason I'm covering all this is because even the best set of headphones in the world isn't going to sound that much better than the runner-up if most of what you're listening to are the problems along the signal chain, including a low quality source, no target response compensation, poor signal-to-noise ratio, and flimsy electrical control over what the drivers are doing. Just for context, here's a set of the Monolith M1060 planars, and until recently, this has been my go-to set of open backs. I'm just going to remove the balanced cable, bring these back to stock, and plug them right into a cell phone. As you might imagine, the sound is unremarkable. Let's call it a 5 out of 10. And when I do the same thing with the Elites, there isn't really that much of a difference. However, and this is a big however, when each of these is being given an individual chance to perform its absolute best with a high-definition 32-bit source, a custom tuning profile, and complete push-pull control of the drivers, the performance gap widens. So, while the initially underwhelming stock performance of the M1060s can be tailored up to a 7, the same process can bring the factory sound of the Elites up to, let's say, a 9. So, there's your value correlation. After all, it's not easy to be a 9 at any price. The time has finally come to clear the headphone wall and set in a couple of these Hercules hooks. That is how the traffic lights attach, and with any luck they might even sit level. Here's the initial power-up, and everything appears to have worked out as planned. The lights look great both as a simple DIY fixture just to slap on a wall and as a purpose-built headphone holder to hang by the sound stack. Before you ask, I'll make this entire project available in printables, which by the way is where you'll also find my other models. In the meantime, however, I've been thinking of an interesting way to perform a sound demo, and if there's one benefit to producing one's own music, it is that granular insight into how each and every sound is constructed, its constituent layers, signal routing, placement along the soundstage, parameter automation, side chains between the individual instruments, etc. And I thought it might be interesting to offer little bits of that throughout the corresponding portions of the track in case you'd like to listen for the same things as I do, though I would actually advise you not to look at the notes the first time around. Also, to make it even more interesting, the Meze Elites will be competing with direct playback, as in me loading the track directly into this video. Before we get started, however, a word of caution. The demo will reach 17Hz at near full amplitude almost immediately, and the headphones are tuned for equal loudness all the way to 15, so please mind your subwoofer if you have one going. And I'll give you a chance to sort that out while I do the closing bit. Right away, many thanks go out to the folks at Meze and to everyone watching. Don't forget to chime in with your listening impressions and the choice of gear that got you there. If you'd like to rate the video, I'd appreciate that as well, and if you're not already subscribed to the channel, then you don't get dessert, whatever. Enjoy the demo, and I'll see you in the next one. Cheers!